So now in this video we're going to look at using an NPN bipolar junction transistor as a current source. We have the voltage at the base, about 0.6 volts gets dropped when it goes to the emitter, but that sets the voltage across the current setting resistor. We're using a trim pot though, and it already limits current unless we go all the way directly to the positive supply. We still want to limit current, so I got a 10 kilo ohm resistor in series with it. But in any case, you're going to see here as I raise the voltage, once we get to about 0.6 volts or so, the LED starts lighting up. And as I turn the voltage up, the LED gets brighter. So that is just a signal voltage. That signal wants to go across the resistor, 0.6 volt drop, remember. But once a little bit of current starts trickling through base to emitter, a lot more current flows through collector to emitter. We have the LED in series though with the positive supply and the collector, so that current also has to go through the LED. However, it still equals the voltage building up to the same voltage we set at the base, minus 0.6 volts right there. Now, since the current does go through the LED though, we're limited probably to about 3 volts total, because the LED, it's red here, drops about 2 volts. A blue LED will drop about 3 volts, so we'll probably be limited to 2 volts across the resistor. But in case that voltage across the resistor divided by its resistance gives you the current, Ohm's law. So here you can see the current we're getting from the power supply. It's not as accurate as a multimeter, but it will work for the purposes of this video. So we got 8 milliamps of current according to the power supply there. And now I'm going to yank the LED because that current should not depend on the load. We're going to get rid of the load by just connecting the positive supply directly. And there you can see it's 7 milliamps. Probably the same amount of current, just the meter is not completely accurate in the power supply. Since we replaced the LED with the jumper though, now we don't have a voltage drop. So we should get the full 5 volts divided by 220 ohms probably right there. But in any case, you can see it's definitely quite a bit higher than when we had the LED. And there we have the LED again, 12 milliamps, as we saw before, just in case you forgot. But in any case, I was thinking of using a voltage to control the LED brightness for an upcoming video. I was going to use the voltage follower, but this is far superior, using it as a current source, so I wanted to make sure I introduce the circuit now instead of later. So, hope you enjoyed.